Hello students, in the last video we learnt about some basic concepts on wave optics. In this video I shall continue. The last video we ended with constructive interference and destructive interference, and the concept was interference, and Young's double slit experiment is what we discussed. So in the Young's double slit experiment there is a source of light and there is a single slit from which light comes, and then there is a double slit and through which light comes into and interfere. That means they overlap and they form alternate bright and dark fringes on the screen. Okay, and this pattern is called interference pattern. Now why do we have a double slit? The reason is they are coherent. Coherent sources of light only can cause interference. Okay, now let me take for example this is a midpoint here and this is the center one, right? And let us say this is the central maximum, and let us say this middle point is O and slit S1 and slit S2, and the central one is the central maximum, a bright fringe. Now if I say that where is the next fringe? Okay, so let us say this is the next fringe. The distance from here is xn, let us say, right? These are all going to happen in only centimeters, right? They are not so large distances. Okay, so this distance we are going to call it as xn, nth fringe, maybe fifth fringe, maybe sixth fringe, eighth fringe, 10th fringe from the central maximum. Where is this fringe? This point is P. Okay, when we derive this equation, we get xn is equal to n lambda d upon small d. You already know that n is the nth fringe, maybe sixth fringe, and lambda wavelength of light used, and d is the distance between the double slit and the screen which we have taken, and small d is the distance between the double slit, that is the two slits we have got. Now this is the point P. If I take the next point Q, that is the very next bright fringe, that will be n plus 1, right? How do I say n plus 1? If I take in sixth fringe, the next fringe will be 7, so I can write it as 6 plus 1, which is 7. So n plus 1 lambda d upon small d. Okay, now I find the difference between these two, right? And that gives me fringe width. Between the two fringes, that gives you the fringe width or fringe of a particular width. Let us say bright fringe. What is the width of it? Suppose let me say for example, this is the bright fringe, dark fringe. Okay, bright fringe. Now if I know the distance between these two, I will be able to know the width of a single fringe, right? So that is called beta. Beta is xn plus 1 minus xn. That is between the 7th fringe and the 6th fringe. What is the difference? When I calculate that, I will get beta is equal to, all this will get cancelled, lambda d upon small d. And this is the formula for fringe width. Now, whether it is a bright fringe or dark fringe, in interference pattern, they are all of equal widths, right? You can try this with a dark fringe also, you will get the same value. So ultimately we take the final value, beta is equal to lambda d upon small d. And also in numericals, we very often use this formula, xn is equal to n lambda d upon small d. So note these 2 points, you should keep it in mind. Okay, so this is the basic of it, the interference pattern, right? Now one may wonder, very often we come across something called, one second please, phase difference. Phase difference and path difference. See, phase, the word phase, it refers to angle, right? And path refers to distance. Okay, so what is it between these two? Let me take for example a circle. Yes, assume a circle like this. Let me form a wave. How should I form a wave? See, I take this part, the upper half of it, yes, and I place the upper half like this. Okay, now this is the upper half. Now the lower half is there, and I bring the lower half here. Yes, now what I form is a wave, right? See, I may be drawn little bit of different size, it's okay, right? Otherwise it is identical, the upper half. So what is this actually? It's a circle. In circle, what is the total angle? 360 degree, right? Now what is 360 degree in terms of radian? It is nothing but 2 pi. That is nothing but 2 pi. Pi is 180 degree. Fine, 2 pi is 360 degree. So, when we talk about path difference and phase difference, we will say path difference divided by path. For example, if this is the point here, the waves are coming from the double slit, let us say. One is coming like this, another is coming like this. We said yesterday, draw a normal. This is the path difference, we said. If that is the path difference, it is in terms of wavelength. So, path difference divided by wavelength should be equal to phase difference. Okay, phase difference divided by. Phase is with respect to angle. What is the total angle? 360 degree. So, 2 pi. So, this is what you should know. Path difference divided by wavelength lambda is equal to phase difference divided by 2 pi. A simple example, let me say. You want to calculate the phase difference. Let us keep here phase difference is equal to, if the path difference is lambda by 2. So let me put path difference is lambda by 2 divided by lambda into the 2 pi comes over here, that is 2 pi. So lambda goes, so you will find that pi 2 pi divided by 2, which is 2 goes, that is equal to pi. So pi is equal to phase difference. So what do you mean? If there is only half wavelength, how much is the total angle here? 180 degree. See, 0 degree, 90 degree, 180 degree, 270 degree, and you reach 360 degree. Keep this in mind. Yeah, the phase refers to angle, path refers to, in a wave it refers to distance. So this is the whole significance. 90, 180, 270 and 360, all of them are within 2 pi. So when you say a path difference of lambda by 2, it means the phase difference will be equal to pi. So this you can use it in the numericals. Okay. Now further, let us move on to the next concept. You should remember that the fringe width of dark or bright or dark fringe will remain same. It doesn't change. They both are beta is equal to lambda d upon small d. Okay. Now I wanted to just introduce the next concept, how the intensity of the light is coming, right? So for example, I got a bulb, let us say, and you say intense light in candela, how the intensity is connected to amplitude. Intensity is proportional to square of the amplitude. How do you measure amplitude for a wavelength? So this is the amplitude. You see, this is A, the maximum displacement. Suppose if I take a wave which is a little larger like this, yes, now the amplitude increases. More the amplitude, more the intensity. In sound also you read, more the amplitude, more the intensity of sound or loudness. We said loudness, here it is intensity. Okay, now if I take this is a single slit here, now I say the intensity of light coming from the slit, from the small space, the hole. Yes, we also can say this is nothing but width of this hole. Yes, so intensity is proportional to A square our width is also proportional to A square. Because the light is coming through only this hole, so naturally the intensity and the width, they refer to one and the same, and they are proportional to the square of the amplitude. Now, when we come to the next point, when two waves overlap with each other, right? So this is constructive interference. Let me draw a little bit more precisely. I hope you understand this intensity concept. Right. Now, let me take a wave. This is a wave. There is another wave which is coming. Let me draw the points. Right. See, they both are identical. Yes. Now they interfere. See, the crust, trough, they both are on the same angle. So you'll find that the output which you will find here, it will have higher intensity, because they add up according to superposition principle, right? Superposition of waves, the intensity will get added up. Okay, this is constructive interference. Now, if these two waves are, they are called in phase. If they are out of phase, okay, that means one is coming up and down, okay, and another is from down to up. Now what happened? The crust meets the trough and the trough meets the crust. Then what will happen to the output? They cancel each other and the output will be just a blank one like this. That is called destructive interference. In constructive interference, it adds up. In destructive interference, they cancel it out. Okay, so this is what you should remember. Now, what is the intensity maximum and intensity minimum? We need to express this in terms of, let me erase it neatly. Yeah, just a second. Yes. See, intensity maximum is equal to amplitude of the first wave plus the amplitude of the second wave, the square of it, right? You add for maximum intensity. Intensity minimum, you get it, A minus A2. We are assuming A1 is greater, or otherwise the difference you can write it, square. Yes? Now, intensity max upon intensity minimum will be simply equal to A1 plus A2 square divided by A1 minus A2 the whole square. Yes, you can write it in simpler form also, right? A1, just bring it down here, A2 plus 1 the whole square divided by A1 upon A2 minus 1 the whole square. Even sometimes people use this instead of A1 by A2 to be simply R. R is equal to A1 upon A2. So we can write it as intensity max upon intensity minimum is equal to R plus 1 upon R minus 1. Simply put the whole square. This also another way of expressing. Yes, I suggest you in examination, you take extra time. Do not worry about taking extra time of maybe 1 minute or 2 minutes. But whatever you do it correctly. Understand the concept. What is the question? Based on that question, you try to answer. Because once you do the problem correctly, you understand the concept correctly and you complete it, you don't need time for revision. In the 12th standard board exams, usually you will not have time for revising the whole question paper like you do in smaller classes, right? In 9th, 10th and all you can do it. But in 12th standard, the time will be so compact so that once you do it, if you do it specifically and carefully with understanding, the chances of error will be less and hence you need not do revision. So do not think I will do one time in hurry and I will revise it. No. You will say that the exam paper was lengthy. No such thing happens. You can complete it within the given 3 hours if you are focused and clear about what you are doing. Yes. With this concept, I move on to the next idea. Yeah. Okay. There is sometime a question which is asked like this. I would like to put it also this. Resultant amplitude, yeah, A. If two waves are interfering, which follows like parallelogram law of vectors in the first year, amplitude of the first one square and A2 square plus 2A1, A2. You remember what we did there? Cos phi. Phi is the angle between the two amplitudes. You can use this formula. Or you want for intensity, you can simply write I is equal to root, okay, I1 plus I2 plus 2 root I1 I2 of cos phi and the whole root. Just wait 1 second please, right? You don't need whole root here because this I1 and I2 is nothing but the root values. Let me write more correctly. Yeah, root, this is, I have removed it, I1 plus I2. Why? I is proportional to A square, okay, plus 2 root of I1 plus I2 of cos phi. Okay, so this is for intensity you can use. I am not deriving anything, please understand. I am only doing revision. So I am just giving you the last minute concepts for you. I have written here, I have made formulae, right? I have written all the formula belonging to this chapter, right? So I have got around 20 formula. So I am just based on this, I am telling you all these points. Okay, one more point I would like to say here, because these are very important for exam. Okay, that is why. If I1 is equal to I2, if both the intensities are same and is equal to some value I0, let us say, then the formula, the total intensity I will become 2 times I0 into 1 plus cos phi. You can use this formula, 2 I0 into 1 plus cos phi, or also you can use it 4 I0 into cos squared phi by 2. See, the max students can understand 1 plus cos 2, 1 plus cos theta is this much, yeah, but what I am saying, those who are in biology stream, you can just mug it up, it should not be a problem at this point of time. You know the derivation, continue with that, and these are very relevant questions from which concept from which questions are being asked, either in 2 mark or in 3 mark. Okay, fine. Now we move on to the last concept of this chapter, that is diffraction. Yeah. Okay. Now what is diffraction? We learned about interference. Now we are learning about diffraction. Diffraction is bending of light near edges or through the holes, slits. If I have an edge like this and light comes and strikes it, what will happen? It will bend. Okay, this bending, this you call it as diffraction or diffraction. Okay, now this is usually in your syllabus, single slit only is there, and the formula goes like that, that is for nth maximum, okay, nth maximum, the formula is A sin theta is equal to n lambda. This is the formula which you will be using, or you can say simply sin theta is equal to n lambda upon A. This is nth maximum. We have nth minimum. minimum. Yeah, that is A sine theta. Just like constructive interference and destructive interference, here also the same thing happens here. That is equal to n plus half into lambda, or simply sine theta is equal to n plus half into lambda upon A. So this is very important. In diffraction, more than the distance, we talk about the angular width. For example, the central maximum, what is the angular width of this central maximum? From the slit it is coming, right? And that is given by the angle. It is going to give you by the angle theta. So sine theta, for small angles, sine theta is equal to theta. So we can simply say theta is equal to n lambda upon A, and this is called angular width, which you should remember, right? And here what is happening? Sine theta is equal to approximately equal to theta, which is n plus half into lambda by A. Yeah, and this is the formula. Okay, remember two things: sine theta and tan theta. The angles are very small, they will be equal to theta. I can give you a small clue for this now. Yeah, you understand what I have done, I hope. Yes. Yeah, before I conclude, 2 points I would like to say. One is interference pattern, another is diffraction pattern. Okay. Look at it. Interference pattern. I am not talking about interference. I am talking about the interference pattern. You can say, take the x-axis, draw the central point. You will find that all the bright fringes are of equal intensity, right? This is, if you keep it like this, upper part. Okay, for different angles, they all turns out to be different values. Yeah, they all come in the same, intensity is same. This represents intensity and this represents width you can take, or you can also talk about distance. Now you come to diffraction pattern. Again, diffraction pattern. Diffraction pattern, all of them are not uniform. Central is bright, then secondary minima, then secondary maxima. Okay, so you will find that the center point you draw, the central will be maximum, then the intensity will go on decreasing, right? And the same thing happens above and below, right? So this is y-axis. If you take it, this is going to be above and below like this, and above and below like this, right? These are the two patterns which you draw, which this y-axis represents intensity. Here you can take angular width or whatever you've been asked, that you can take it. Fine. Yes, I hope that with this we have completed wave optics, majority of the concepts. For 2021 examination, you do not have polarization. Polarization is not there in the syllabus this time. Okay, so it's very simple to wind up. Okay, very easy. You can score 3 to 5 marks in this area. Okay, you started with Huygens principle, application of Huygens principle in reflection and refraction, then move on to interference, then learn about interference patterns, then move on to Young's double slit experiment and interference pattern, then you move on to diffraction and diffraction in a single slit, and then you move on to the diffraction pattern. Okay, these are the main concepts which you will find, and there are plenty of numericals. You can try 2 numericals. I want to complete this video with a small conceptual idea. When you take a circle and this is the center and this is the radius and this is another radius and this is the arc I have taken, arc length L, and this is theta. You know that the arc length divided by radius is the angle subtended. Okay, this is what we have learnt. Now, let us take a right angled triangle. In a right angled triangle, this is the angle theta, this is the opposite side, and this is the adjacent side, this is the hypotenuse. Okay, let us define sine theta. Sine theta is equal to opposite side upon hypotenuse. We know this. But if this theta becomes very small, then this perpendicular more or less behave like an arc. Okay, and you can say this is nothing but the radius and this arc length. Okay, so simply you can say arc length upon radius, then sine theta will become simply approximated into arc length upon radius, right? If you want, I can make it more clear to you in this point here. Fine, see here like this you can take, okay, arc length, this is the perpendicular you are drawing, fine, and when you come closer and closer, you'll find that more or less this becomes narrowed down. Now what about tan theta? Same principle. Tan theta is equal to opposite side by adjacent side. Opposite side again comes closer and this becomes L, and adjacent side is R, so L upon R. So tan theta is also approximately equal to theta is equal to L upon R. So this is how, but cos theta cannot be. Cos theta is the adjacent side by hypotenuse. There is no perpendicular coming into the scene. So cos theta cannot be approximated. Only sin theta and tan theta can be approximated. So let me cross check my notes in my hand. Okay, I hope I have introduced all the concepts to you. Yes, one point I missed it here. What will happen to fringe width if you place the double slit experiment in water or in some liquid? Then fringe width beta dash will become beta upon refractive index of the substance, the medium. So the fringe width will decrease when you keep in a particular medium, that is like water or something like that. Okay, that is one point you should keep it in mind. Otherwise I have generally covered all the points. Okay, I hope you are utilizing my short videos, revision videos. From your comments I can understand that you are utilizing it. Thank you so much. Next video I will come with the optics, that is ray optics, with more ideas. Thank you so much.